In the world of business analytics, there's this huge battle going on. It's not about which charts look best, but something way more fundamental: how we actually organize our data. And trust me, the choice you make here has massive consequences for speed, for cost, and for how flexible you can be down the road. So let's break down the two main contenders in this fight. Really, it all boils down to this one question. When you're racing for insights and every second counts, what's your bet? Do you go with the classic, super organized star schema? Or do you go for the raw, brute force power of a single flat table? This, right here, is the great data debate. All right, first up in the ring, we have the reigning champion. This is the approach that's been the gold standard in data warehousing for decades. Let's talk about the star schema.
So, how does it work? Well, its structure is actually pretty elegant. Right in the middle, you've got your fact table. This is where all your numbers live. Think sales figures, inventory counts, all the juicy metrics you want to aggregate and analyze. Then, connected to that center table, like the points of a star, are your dimension tables. These give you all the context, the who, what, where, and when behind those numbers.
The classic data warehouse toolkit has the perfect analogy for this. A star schema is like a master chef's pantry. Every single ingredient, every product, every customer, every date is neatly labeled and stored in its own separate container. This gives you incredible flexibility to just grab what you need and combine them into any analytical meal you can dream up.
Now, this level of organization has some huge advantages. Your dimensions, like a calendar table or a customer list, can be reused over and over for different analyses, which is super efficient. But, and this is a big but, there's a catch. To cook that meal, you have to go pull ingredients from all those different containers and put them together. In the database world, we call these joins, and they can be the single biggest thing that slows your queries down.
And that slowness from joins? That's the exact weakness our next contender is built to exploit. So meet the aggressive challenger, the flat table, or as some people call it, the one big table.
The philosophy here is brutally simple. Joins are slow, so let's just get rid of them completely. A flat table takes all that context from the dimension tables and just crams it into one single, massive, super wide table right alongside the numbers. We call this denormalization. You're basically repeating information over and over again on purpose just to make every single row completely self-contained.
Let's head back to our restaurant analogy. If the star schema is that well-organized pantry, the flat table is like a wall of pre-packaged meal kits. You want to make spaghetti? You just grab the spaghetti box. Everything you could possibly need is right there, ready to go. For that one specific meal, it is unbelievably fast. And right here, you see the fundamental trade-off, don't you? The pro is just undeniable. Your queries are going to be lightning fast. But the cons? Oh, they are severe. You get massive data redundancy, which means your storage costs go way up. And what happens when you want to add a new type of analysis or change something? It can be, and I'm quoting a data professional here, a nightmare to scale.
But there is a really powerful argument for this approach, especially today. This quote from a data practitioner on Reddit just hits the nail on the head. Modern cloud systems use what's called massively parallel processing, or MPP. They take a huge task, chop it into tiny pieces, and get hundreds of computers to solve it all at once. Joins make that really hard, but a giant flat table, that's super easy to slice up and distribute.
And that brings us to the modern arena, where this debate is really playing out: the cloud data warehouse. Because here, the rules of the game have totally changed. This is where all the theory gets put to the ultimate test.
See, in the old days, we had one big, powerful server. Now, we have clusters of hundreds of smaller ones. But the biggest game changer is columnar storage. Instead of storing data row by row, these new systems store it column by column. This is a huge deal for analytics because most of the time, you're just aggregating a few columns. Columnar databases can read only those columns, which speeds things up like crazy and makes those dreaded joins way less painful.
And the arena is packed with titans. I'm talking about systems like Amazon Redshift, Snowflake, Google BigQuery, and Vertica. These are the platforms where theory meets reality. And performance? Well, performance is everything.
So researchers decided to put them to the test. And the results? Well, they're probably not what you're expecting. Just look at that first row for databases like Redshift. The classic star schema actually won. The tech was just that good at optimizing joins that the organized approach was faster. But then, look at the others, like IBM's DB2 or the new SQL systems. In those cases, the raw join-free speed of the flat table took the crown. The takeaway here is crystal clear. There is no single winner.
But wait, here's the real kicker from that same study. Even on the systems where the flat tables won for performance, on average, they were 4 to 5 times larger in storage size than the star schemas. That is a massive trade-off between speed and cost that you just cannot ignore.
So, with all this conflicting evidence, what's the verdict? How in the world are you supposed to make the right call for your business?
Let's ask it one last time. Star schema or flat table? Who is the ultimate champion?
The answer is, it depends. I know. That sounds like a total cop-out, but it is the absolute evidence-based truth. Believing there's only one right way is your enemy here. Context is everything.
So how do you decide? Well, here's a simple 3-step framework you can use. First, analyze your workload. Are you running the same few predictable reports over and over? That flat table meal kit might be perfect. Or are your analysts constantly exploring, asking new questions out of the blue? They're going to need that star schema pantry. Second, you have to understand your tech. As we saw, Redshift and TiDB behave very differently. And finally, balance the trade-offs. This isn't just a tech decision, it's a business decision. You're choosing between raw speed, storage costs, and your flexibility to adapt down the line.
Okay, let's bring this all home with one final thought that looks beyond today's debate and into the very near future.
As we rocket into this new era dominated by AI and machine learning, the demand for instant, on-the-fly insights is just exploding. And these new AI systems, they often thrive on simple, massive, denormalized data sets. So the question I want to leave you with is this. As the need for speed becomes more relentless than ever, will it finally force a clear victory for the flat table? The great data debate is far from over.